All right, we're doing a little bit more AP review. This is 2012 AB Free Response 6. It is AB only, the BC question was different. So for time 0 to 12, a particle moves along the x-axis. The velocity of the particle at time t is given by v of t equals cosine of the quantity pi t over 6, or pi over 6 times t, whatevs. The particle is at position x equals -2 at time t equals 0. So I just wrote that as x of 0 is -2. Cool. So we're given velocity. It is a non-calculator question, and we are given one specific position and a time window. All right. So for t equals 0 to 12, when is the particle moving left? So in the window from 0 to 12, when is the particle moving left? So this is one of those situations where the first thing we should really do is think about what it means to be moving left, right? So what they ask is moving left, right? So that's the thing they ask. So then you want to translate that into what that would mean mathematically. Like, what is the definition of moving left? Well, on the xy, like in the x direction, right, on the x-axis, moving left means the velocity is negative. So that means v of t is less than 0, right? That's what it would mean to be moving left. So now it's our job to find that window, right? The easiest way to do that, right? So the easiest way to do that is to find when v of t equals 0 and make a sign chart, right? So the easiest thing you can do is find v of t equals 0, right? And then make a sign chart. So 0 equals cosine of pi over 6 times t. Remember that cosine is the x on the unit circle. So if you're asked where the x on the unit circle is 0, it's at these spots on the y-axis, right? Pi over 2, 3 pi over 2, etc. Well, the trick is that my window's from 0 to 12, and I have a pi over 6 in front of my t. So my pi over 6 t is going to equal, and then I'm just going to list a bunch of these, right? Here's my argument. You should list a whole bunch of these, and then when you clean it up, if any of them are too large for your window from 0 to 12, then that's actually a good sign, and you know to cross off the one that's too large. The danger is that you risk not including all the ones that you would want to include if you don't actually pass 12. So when I solve, I'm going to actually times each of these by a 6 over pi, right? So I'm going to times this pi over 2 by a 6 over pi, right, which is going to end up giving me a 3, right? And then I'm going to times this 3 pi over 2 by a 6 over pi, right, which is going to end up giving me a 9, right? So that's a 6 over 2, which is a 3. That's an 18 over 2, which is a 9. And then when I times this guy, 5 pi over 2 times the 6 over pi, I'm going to end up getting a 15, which is too big, right? It's too big because my window is from 0 to 12. Again, the advantage to going a little bit farther than you think you have to, right, to keep going in 7 pi over 2 and 9 pi over 2, etc., is if you know you went to the one that's too big, you know you can't possibly have missed an answer because you didn't, if you only went as far as 9, what if the next answer had actually been in the 0 to 12 window and you just didn't realize it? By actually going too far, you can be like, oh, wait, that's too big. I didn't need that guy that whole time. But you didn't know you didn't need that guy until you solved. So, cool. Anywho. So there we go. We have t is 3 and t is 9, right? So that's when this particle is at rest. For the record, if you were asked, that's when you're at rest, right? When v is 0. And so then you need to consider the sign of v of t in the windows. So there's a couple different ways to deal with this. One way is to realize that this was actually equivalent to that answer that you got, which was a 3, and this was equivalent to that answer that you got was a 9. And so in this window, from 0 to 3, you can see the x-coordinate is positive, right? And then in this whole window, you can see the x-coordinate on the unit circle will be negative. And then in any window afterwards, you would have a cosine that's positive, right? And you don't get back all the way around. So one way to do it is actually use your unit circle knowledge to say, oh, I get it. I start at 0. From 0 to 3, the x-coordinate would be positive, right? Since v is cosine, my v is positive. From 3 to 9, the x-coordinate, which is the same as the cosine of something, the x-coordinate on the unit circle, would be negative. And then from 9 until the end of the problem, which is at 12, it would be positive. And if you do it that way, then your answer is that you're moving left in this window right here. So you are moving left in the open interval from 3 to 9. Right, so from 3 to 9 is when you're moving left. The other way to make your sign chart is actually plug in values between these numbers into cosine, which is absolutely fine. The other way, so if you had wanted, you could have tried plugging in the number 1, right, because that's between 0 and 3. So cosine of pi over 6 would have come out as a positive number. And then you could have tried plugging in, like, I don't know, the number 6 is an easy choice, and cosine of 6 pi over 6 is a -1, so that would have come out negative. And you could have tried plugging in I don't know, let's just go with a 10 here, because that's an easy number. 10 pi over 6 would be the same as a 5 pi over 3, which is right here, and sure enough, the cosine there is positive. So there's different ways that you could make your sign chart, but that's the answer that you need for part A. All right, cool. So let's talk about part B. Write but do not evaluate an integral expression that gives the total distance traveled by the particle from time t equals 0 to t equals 6. So the thing is, if you're not asked to evaluate this, you can use the really awesome cheat that we usually only use on a calculator. So if you want to find total distance, there are a few different ways to do it, right? But the easiest way to do it, the easiest option, is if you're allowed to integrate the absolute value of velocity with respect to time from A to B, because this would be integrating the speed. If all you do is integrate your speed, which is a scalar, you get total distance, which is a scalar. So the total distance on the window from like A to B, right? So that's great, right? And because in part B they did not ask us to evaluate the integral, we can absolutely just do that. We can say, cool, I'm integrating from 0 to 6 of the absolute value of v of t dt. And that's great. So this is the easiest of the correct answers, right? It is the easiest, and it is okay because you're asked not to evaluate, right? Asked not to evaluate, right? But on a non-calculator section, if they had asked you to evaluate this, right, what you would have to do instead is you would have to integrate between stops. Now, the other way to do this, right, the other way to do this problem is you can find displacement between stops and then absolute value it. Sorry, you guys can't see that. There you go. Absolute value it to get the distance between stops, right? So in this problem, my stops were at 3 and 9. So in this problem, right, if I want from 0 to 6, I was only at rest at t equals 3, right? There was another spot I was at rest. It was t equals 9. But in this problem, the only spot that I was at rest from 0 to 6 was 3. So if you want to do this the other way to do this that is more complicated but is doable by hand is you would integrate from 0 to 3, which is the first leg of your trip, and you would integrate the velocity, but then whatever answer you get, you would take that quantity and make it positive. The reason you can do this without a calculator but you can't do this without a calculator is integrating absolute values inside an integral are very difficult. But integrating and finding a number and then making it positive is not difficult. And then you would add that. So this would be the distance on the first leg of your trip, right? And then the distance on the second leg would be from 3 to 6, because they said end at 6. V of t dt, that would be your displacement on the second leg, but in order to make it distance, you would again take whatever answer you got as your displacement and say, oh, but that should be positive, and that would be the distance on the second leg. So this answer would be correct as well, like this whole big messy answer is the same as this much simpler answer. Here, this is all the AP wanted, because they didn't ask you to integrate, they just want you to set it up, so this is great and totally awesome. If you had been asked to do it by hand, you would have had to use this option. And that's pretty much what you would have to do. All right, so anyway, moving on. Really, again, part B was just this, and it was only worth 1 point. But if you were asked to integrate, you'd have to use this method. All right, part C. Find the acceleration of the particle at time t, and then they ask, is the speed of the particle increasing, decreasing, or neither at t equals 4? Explain your reasoning. Okay, so we now need to make sure we understand the relationship between velocity and acceleration. So remember that acceleration is the rate of change of velocity, right? So my acceleration, right, is just going to be v prime of t, right? So when I derive this, I need the chain rule. Derivative of cosine is negative sine of whatever's inside the sine times the derivative of the stuff inside the sine. So I end up getting that a of t is negative pi over 6 times the sine of pi over 6t. So that's my a of t. So that's the first thing they asked me to do, right? Awesome. First thing. Second thing they asked me to do is they ask if at t equals 4, right, they ask, is the speed increasing, decreasing, or neither? So when we talk about speed increasing, right, so they ask, is the speed increasing? Is the speed decreasing? Or is neither of these things happening, right? Neither. My bad. All right. So the other way you'll hear speed increasing is the colloquial phrase speeding up, right? That's the other way you'll hear speed increasing, and the other way you'll hear speed decreasing is slowing down, right? Those are the colloquial phrases that mean the same thing, right? Okay, so we should talk real quickly about what those two things mean, and if you know what they mean, then this is a very easy question to answer. So speed increasing happens in one of two situations. It happens either, well, short version is it happens when A and V have the same sign. So this is if A and V have the same sign, right? It doesn't matter which sign, but if A and V have the same sign at t is 4, when we plug in 4, then the speed is increasing. And I'll give you both of the analogies that I will at some point mention in another video way back when in a lesson. So the two examples of speeding up, okay, so if I'm a bad driver and I see a yellow light, my velocity is positive because I'm moving forward towards the light, and then I see the yellow light and I hit the gas. Well, that means my acceleration is also positive. So with positive velocity, car moving forward, positive acceleration, I hit the gas, my speed is increasing. I'm speeding up, right? But there's the other example of when they have the same sign. And so that one's fairly intuitive. I think we're all good at that. The one we're less good at here is the one where they're both negative. So I jump out of an airplane. My velocity is absolutely negative. I am plummeting towards the ground, right? My acceleration is also negative, right? The acceleration due to gravity is like a negative 9.804 meters per second squared. So both acceleration and velocity are negative. I am absolutely speeding up as I plummet to my death, right? So again, if A and V have the same sign, I'm speeding up. So the converse of that is that if A and V have opposite signs, right? If A and V have opposite signs, then I'm slowing down. And there are two scenarios for that as well. So the more intuitive one is the stoplight scenario. I'm driving towards a traffic light. I see that it turns yellow. My velocity is positive because I am driving forward. But when I see it turn yellow, I hit the brakes. So now my acceleration is negative. Velocity positive, acceleration negative, I'm slowing down. Cool. That one makes plenty of sense. The one that is less intuitive is the one where I jump out of the airplane. So I jump out of an airplane, right? It's less intuitive for lots of reasons, like, hey, I jumped out of an airplane. What was I thinking? So I jump out of an airplane. My velocity is negative. My velocity is going to be negative the whole time. I never stop moving downward, right? I'm always moving down. But when I pull my chute and the chute opens, because of the drag created, I'm not just in free fall. The acceleration due to gravity is not my acceleration anymore. So my acceleration briefly becomes positive, right? The drag from the chute makes my acceleration positive, right? And then as a result, I'm slowing down, right? So I slow down because my velocity is still negative, but my acceleration becomes positive by the chute that opens. So all of that, talking about those four scenarios, is mostly just to explain to you that really all I need to do in part C, once I find acceleration, is plug in T as 4, and it's going to be one of these two situations. Now you might say, hey Hogan, if it's one of those situations, why did they throw in the neither? Well, notice that both of these depend on the signs, right? So if either velocity or acceleration is 0 at 4, well then I'm going to have to say, whoa there, it's not either of these situations, because there is no positive or negative 0. 0 is in its own category, there is only 0. So these rely on non-zero values of A and V. So if you get a 0, then you would talk about neither. That said, I think it's pretty rare that that's the situation. Maybe I'm wrong, maybe it's neither this time, but it seems pretty rare. So let's go ahead and find V of 4. Right, so V of 4 is going to be the cosine of 4 pi over 6, which is the same as the cosine of a 2 pi over 3, right? So if you look at cosine of 2 pi over 3, right, cosine of 2 pi over 3 is right here, right? That's definitely a negative x-coordinate, right? Because remember, cosine is the x-coordinate on the unit circle, so I don't even need to know what number it is. I mean, you can go ahead and say that it's negative 1/2 if you want, but really all we need to know is that it is a negative number. And A of 4 is going to be negative pi over 6 times the sine of 2 pi over 3, right? And so this is the y value at 2 pi over 3. So again, I'm going to point out that I don't really care what the number is. I mean, if you want to know that that is a root 3 over 2, that's great. Like if you want to write that this is a negative root 3 times pi all over a 12, right? Nobody's going to blame you and say that's wrong, but again, really all we care about is that it's less than 0. So see how both of them are negative. So I have a situation where my speed is increasing because both A and V have the same sign. So I did the work to back it up. I show what the signs are, and then I say, hey, now that I know they have the same sign, I'm in the situation where speed is increasing. All right, I blabbed a really long time for that part C, so let's go ahead and do part D. All right, so part D. Find the position of the particle at t is 4. Okay, so this is that first fundamental theorem of calculus question. So the mental leap here is to recognize that v of t is the same as x prime of t. Remember that the first fundamental theorem of calculus, we see this over and over again. If you want to integrate from a to b of some f prime of x dx, you get f of b minus f of a, right? That's the generic first fundamental theorem of calculus that we see all the time, right? The one we're going to use here is instead of integrating f prime of x, we're going to integrate x prime of t. So if I integrate x prime of t from, I know x of 0, so from 0 to 4 with respect to t, I'm going to get x of 4, which is a value that I want, minus x of 0, which is a value that I was given. Sorry, that's not in any way how you spell the word given. And this is an integral that I can do. I should be able to integrate from 0 to 4 of cosine of pi over 6t dt. So I'm going to go ahead and add over the x of 0, which I now know is a negative 2, and say, cool, that's x of 4. So this is what I want to integrate. How much work you need to do, like if you need to do full u sub here and make your u the pi over 6 times t, that's totally fine. If you're comfortable recognizing that since this is the inside of your cosine, every time you derive this thing, just like we saw when we did a of t, I would have to times by pi over 6. So if I integrate this thing, I'm going to have to times by 6 over pi, or essentially divide by pi over 6. So when I integrate this, I get a sine of pi over 6 times t, right? But then because of this integration with this what would be u sub, I would have to divide by a pi over 6. So I'm going to go ahead and put a 6 over pi at the front. From 0 to 4 plus this negative 2 should give me my x of 4. And so now I'm going to plug in some values. I get a 6 over pi times the sine of 2 pi over 3, right? So that's what 4 6 would be, right? Minus a 6 over pi times a sine of 0, which will totally go away, minus a 2 equals x of 4. So when I clean this up, which presumably I'll do over here because that's a little bit of space for you, I get that x of 4 is, this guy's a 0, right? And this guy is a root 3 over 2. I think I can cancel the 6 and the 2 to get 3 root 3 over pi minus a 2. So I think I get 3 root 3 over pi minus a 2. And that is my final answer.